Hello, this is the video on 3-digit integer multiplications by Vedic Math. My name is Ganapati V. Narayanan or simply Nara Narayanan. Now let's talk about the Vedic period and Sutras. Vedic time period is between the year 2000 BC and 200 BC. Sutras were decided during the Vedic period as part of the various religious rituals. The word sutra, spelled S-U-T-R-A, sutra, has the English translation of lineage of or length chain or as a thread chain of ideas and methods. There are 16 sutras and 13 sub-sutras that are recited during the Vedic period and then written out during the year 500 BC and 200 BC on various materials. These sutras are meant to provide classical rules of mathematics as the then computational numeric method, as I call it. We consider these today in the modern times as the usual arithmetic methods taught in our primary schools. We discuss in this supplement only the Vedic rule used for multiplication. This is the important sutra that helps us understand the classical multiplication of integer methods. This Vedic sutra in the Sanskrit language is known by Urdhva Tiryabhyam Prayogam. Urdhva is translated as vertically and Tiryabhyam translated as crosswise, and Prayogam means method. How this Vedic sutra can help explain the method is detailed in the following slide. Before we do understand the Vedic multiplication rule, Vedic multiplication by the Vedic rule, we need to know the digital addition multiplication. It is important to know the digital multiplication and addition before we can understand any numerical method. We can create table of digits of addition and multiplication. These tables can be memorized in order to perform a successful digital addition or multiplication. These tables are taught in primary schools, thus any school or college students is very familiar with these tables. For completeness and formalism, the tables are presented on the next two slides. Please refer to them as necessary. Addition table for digits. Addition table of digits that everyone interested in math, in developing numerical methods or in writing programs should know implicitly in mind. For example, the row 1 is the digit added to the digits on column 1. So for example, if I say 2 plus 2, then the result is 4. You can draw a line on the third row under 2 and the third column under 2, and wherever it meets you see the result as 4. Same thing we can do for multiplication. The multiplication table must also be memorized and one must know this fully in mind. Similar procedure of knowing the result of multiplication of digits can be seen by following the column and the row respectively. If I say the multiplication of 4 by 4, then we see the fifth row under digit 4 and the fifth column under digit 4, and wherever it meets you see the result as 16. Now let's come to the multiplication of 3-digit integers. Let's see with an example how the usual multiplication taught in primary school is done. For example, let's take multiply 469 multiplied by 675. For usual primary school method, we multiply 466 first by unit digit 5, then by tens digit 7, and then by hundreds digit 6. We perform the addition of these three results after placing results at appropriate digit locations of units, tens, and hundreds digit location. Let's elaborate this with more details. On this slide, you'll see the number 469, which is usually called the multiplicand, and the number integer 675 that is usually called multiply. Now what we do is we go from right to left digit of the multiply. So under 675, digit 5 is the unit digit, digit 7 is the tenth digit, and unit 6 is the hundredth digit. So we multiply first by 5, and the result is 2345 as shown. If we multiply 469 by 7, the result is 32830. And if we multiply 469 by 6, then the result is 281400. And if we add up, you end up with 316575. 316,575. Of course, if we show this individually, the results can be seen on this slide. 469 by 5. When I multiply 9 by 5, it is 45. When I multiply 5 by 6, it is 30. When I multiply 5 by 4, it is 20. And now this includes the carryover. So we take the carryover 45, which is 4, to the left digit, which is 10th digit. And so it becomes 30 plus 4, 34. Now we carry over the 3 of 34 to the left digit and write 4 there. And so 20 plus 3 is 23. So the answer of multiply 469 by 5 is 2345. Similarly, if we multiply 469 by 7, 7 times 9 is 63. Of course, this is 10th digit, so we write this under the 10th digit. 7 by 6 is 42, and this is 420, so we write under the 100th digit. 7 by 4 is 28, and this is the 1000th digit, so we write under 1000. And we separate the carryover, so the 63 and the 10th becomes 3, and then carry over 6 to the left digit. So 42 plus 6 is 48, and then we carry over the 4 to the left digit. So 28 plus 4 is 32, and so 3 is carried to the left, which is 10,000. So the answer is 32,830. Similarly, if you multiply 469 by 6, then 6 times 9, 6 is under the 100th digit. So the answer is 5400. So we write under the 100th digit. 6 times 6 is 36. And this is the 1000th digit. So we enter under the 1000th digit, 36. 6 times 4 is 24. So we write under the 10,000 digit. And we carry over, separate the carry over to the left. And so 54 under the 100th digit will become 4, and carry over 5 to the 1000, and so 36 plus 5 is 41, and carry over the 4 to the 10,000 digit, so 24 plus 4 is 28, and so we carry over the 2, so we get 261,400 as the result. Now if we add up the 3 individual multiplications, we end up with 316,575. Of course, we can explain this with the modern algebraic multiplication rules as rule number 1 and rule number 2. Rule number 1 is stated as a multiplied within the parenthesis c plus d equals a times c plus a times d. That means we distribute a inside the parenthesis c plus d. And this second rule is an extension of the first rule, where we have 2 parentheses. The first parenthesis inside we have a plus b multiplied by the second parenthesis inside c plus d. So we distribute a first inside the parenthesis a c plus d, and then we do the b distribution inside the parenthesis c plus d, and end up with a multiplied by c plus d, b multiplied by c plus d, and use the rule number 1 and get the result as a times c plus a times d plus B times C plus C times D. Of course, we can explain our multiplications using the algebraic rules, which we will not dwell here much. Now, if you use the Vedic rule, and the Vedic rule states as Urdhva Tiryag Vyam Prayogam. Urdhva means vertically, Tiryag Vyam means crosswise, Prayogam means method. So we use the Vedic rule now and explain this type of multiplication on 3 digits. Of course, we use some notation so that I can simplify this on the slide. So I use capital X for cross, that means multiplication, and symbol N2D, capital N2D, seen here at the top, where we say digit number of digits, 2 digits at a time, and then we have X N3D, that means we have number of digits, we have to use 3 digits at a time, and then we use X cross N2D, the next 2 digits, and then we vertically multiply the right digits. So if we have perform the multiplications, and let's take a blank sheet of paper and see how this is done in a little more detail and come back to this slide. So we write, now we have 543 multiplied by 472. 543 is called the multiplicand, 472 is known by multiplier. So we take the first digit, in this case 543, the first digit is 5, and we take the first digit of the multiplier, which is 4, and we multiply it vertically, so we do the vertical multiplication. So 5 times 2 is 20. Now we take that first 2 digits of 543, which is 554, and we take the 2 digits of 47, and this next 2 digits we multiply by 47, so which means the result will be, and we cross multiply, so which means that the result will be 5 times 7 plus 4 times 4. And then we take the 3 digits together, in this case the 543 by itself and 472 by itself, and we use the cross multiplication. And in this cross multiplication, if I write it in a larger format, so I can show you the cross multiplication with 5 and 2, 4 and 3, and 4 and 7. And so we end up with 5 times 2 plus 4 times 3 plus 4 times 7. Now we take the next 2 multiplication, next 2 digits, and now if you move away from 5, so we end up with 43 as the first number, first integer. The second one is 72, and we do the cross multiplication. Similarly, 4 times 2 plus 7 times 3. And we take the last digit, vertical multiplication, and so the last digit is 3 of the multiplicand, 2 of the multiplier, and so we end up with 6. So the result is 20, and then 5 times 7 is 35 plus 16, which is 51. And then 5 times 2 is 10, 4 times 3 is 12, so it is 10 plus 12 is 22, plus 4 times 7 is 28, so 22 plus 28, which is 50. Next one is 4 times 2, which is 8, and then add 7 times 3, which is 21, so it is 29. Then 3 times 2 is 6. We do the carry over and carry it to the left of the digit, because we need single digit within the parenthesis. So the first one is 6, the second one is 9, we carry over 2 here, the left, so 50 plus 2 is 52, so we carry over the 5 to the left, so 51 plus 5 is 56, so we carry over to the left, and so we end up with 5 and then 2. So the result will be 256296. So we come back to this slide. Now you can see what I have done on the other sheet by hand. So first thing is left digit multiply vertically, and so this is 5 times 4, 5 times 4, which is 20. And then we take 2 digits at a time and multiply. So the multiplicand is 5 times 7. The cross multiplication is 5 times 7 and 4 times 4, which will be 51. And then we end up 51 shown here. Then we multiply 3 digits at a time. 5 times 2, 5 times 2 plus 4 times 3 plus 4 times 7, and we end up with the digit 50. And then we do the next 2 digits, which is 43 multiplied by 72. And so 4 times 2 plus 7 times 3, which is 29. And then we multiply the last right digit, 3 times 2, that is 6. And we carry over the we perform the carryover, and so we end up with 256296. I'm planning to give 5 exercises that you can do the Vedic multiplication and then check your results by the usual primary method. The first one is 328 multiplied by 637. The second one is 681 by 248 multiplied by 248. The next one is 956 multiplied by 549. The next one is 843 multiplied by 756. The next one is 723 multiplied by 548. I've gone slow so that this slide remains on the video, but what you can do is you can write these numbers down on a sheet of paper before you do the work so that you won't have to wait on this slide. Or the best way is also to pause this video at this point and then make a screen cut of this slide and copy and paste, cut and paste on your Word document or other documents, and then print it out so you have these exercises on hand. Now I'm going to give 2 references for the Vedic rule. Of course, this is only Vedic multiplication of 3 digits, but you can get more details on other types of multiplications. And I have put videos of the other multiplications, but you can use these references also as a supplement to these videos. The first one is the Udemy course on mental methods by Vedic Math taught by Arnab Ghosh. This is a 5-hour video course, and of course it doesn't cost much. It may be $10 to $15 on Udemy. The second one is a book on the essentials of Vedic math, written by Rajesh Kumar Thakur, who is the director of National Vedic Math Academy in India. And this book is very detailed in explaining Vedic math and applications in all areas of math, of multiplication, addition, subtraction, subtraction, square root, cube root, etc. Thank you very much for watching this video, and look forward to meeting you in other videos.